Hello everyone, it's Peter. Welcome you back. This is a very easy session with exception handling, and this is file input and output. For exception handling, we already used some exceptions before, like clone not supported exception. When we talk about the clone and the clonable, that's a checked exception. And we will more focus on the concept-wise things in exception handling. The most important one is checked and unchecked exception. This is also frequently asked in the interview. So you can see this diagram. This is a exception class hierarchy. The top level is called throwable. Throwable is a concrete class. You can use throwable. Then there's an error and exception as two subclasses. And exception, there's a runtime exception. So there are also some other subclasses, but we can divide it into two different categories, like error or any subclass of error are unchecked. Exception or any subclass of exception, but not subclass of runtime exception is checked. And the runtime exception is unchecked, and any subclass of runtime exception is unchecked. You can also define your own exception. Like I define my exception. If my exception extends exception, then it's checked. If my exception extends runtime exception, then it's unchecked. Okay, it's unchecked. So then, what's the real difference between checked and unchecked? So I give a summary. Checked exception can be considered as a compile time exception. It must be handled during compile time. It means for checked exception, a good example is a clone not supported exception. If you know the method will throw this exception, and then you have to handle it. How to handle it? How to handle an exception? Two ways. The first way is try catch block. You can use try and catch. The second way is you use throws this exception in class in method declaration. So this is how to handle exception. Now unchecked exception is also considered as a runtime exception. It happens during runtime. It may or may not be handled during compile time. Okay, so this is the concept. To understand this concept, I can make an example. So I go to this simple JDoodle. So I can define a class, say my exception. I can extend exception or runtime exception. If I extend exception, it means that my exception is this is checked. Then my exception is checked exception. Now, so in the code, so I can have let's do int x equal to 10. If x mod 10 mod 2 is an even number equal to 0, then I throw an exception. Throw new my exception. I can do this. So I can write something inside, but I don't write now. So then I give this condition, and if x is an even number, I throw new my exception. So can this code work? Actually, if you execute it, see, unreported exception, my exception must be caught or declared to be thrown. So this is the way, actually it gives a hint of how to handle this exception, because this is a checked exception. So you must handle it. So it shows that at the end I print out end of main. I print out this one. Okay. So it means that my exception is a checked exception. It must be handled during the compile time. That's why that is the compile. If you don't handle it, it will have a compile error. So how to handle it? You can use try, throw exception, then catch my exception, print out, handle my exception. Okay, so then you execute. See, there's exception thrown, and you handle exception, then end of the main. Okay, you must handle it. This is a checked exception. But if you extend runtime exception, that's a different story. This is a unchecked exception. Unchecked exception means you may or may not handle it. So you can run it. See, you can handle that, or you don't handle it. You just then I just delete it, throw new my exception. Okay, then it also works. But if you in this code, if you don't handle it, it will stop at this level. It won't throw out. It won't go to the line 7 to go to end of main. Exception, right? Exception as thread main my exception. So it means this is a runtime exception. During the compile time, there's no problem. It only happens during the runtime. You may or may not handle it. This is a runtime exception. And for the text exception, right? There's a compiler, so I can use another way is throws my exception. You can also use this way. So it's another way of handling it, but it's not really handling it. Just throw it back to the caller, and that caller to handle it on the upper level. But the upper level is OS, so it's throw exception on the OS side. But if this is in a method, so on the caller side, you can use try catch to catch it as a checked exception. So in this example, we know two things. First is understand what is checked and what is unchecked. Checked is a compile time exception. Unchecked is a runtime exception. Checked must be handled, and unchecked may or may not be handled. The second thing is that any exception which extends runtime exception is unchecked. Any exception which extends exception, this is checked. Okay. This is very important to clarify that. Now, next is about the try catch block. So we know use try catch to handle exception. And then there's a finally block. There's a finally block. And there's one thing is in which case the code in finally block will not be executed. So I don't want to write code in our this Java code, so I just run here. What is finally block? Let me give you an example. I can write a static int check. I say verify int number. Okay. Now let's use try. So if n more 2 equals to 0, if it's an even number, then I throw new exception. Okay. And then I can catch exception. Catch this exception. In this exception, I print out exception with input plus n. For this input, we have exception. Then I have in the catch, I return 10 because that has to return something. In the finally block, so in finally block, then I return 20. For the normal one, if this one, if this condition does not hold, even if it's an odd number, I return 30. Let's see what happens. Okay. int result equals to verify let's say verify 3, then we print out result. We can see the order. Execute. Throw my exception. On this one, there's no definition of my exception, so let's run it. Okay, look at this. 3. You can see 3 mod 2 equal 0 is false. It won't throw any exception, so it returns 30. But there's another finally block. It means finally block is always executed, so it runs in finally block, and the result is 20. See, the normal execution it returns 30, but the finally block is returned 20. It means finally block has the highest priority. Remember that has the highest priority. So if the try block returns 30 and the finally block returns 20, then it will return 20. So result is 20. So in this case, there's no exception. Okay. Now the second case, I verify 4. For 4, this is an even number. I throw new exception, and it will go to the catch block. The catch block will print out exception with input 4, and the catch block will return 10. Again, there's a final block. Final block will return 20. So which will be returned, 10 or 20? The answer should be 20, still 20. In final block, result is 20. So through this example, we should understand what is finally. Finally block is optional. You may or may not add finally block, but if you add finally block, then the final block is guaranteed to be executed. If the final block returns something as in the method, and this one should be returned, no matter what happens in the try block or catch block. Now, next question is, in which case the code in finally block will not be executed? Why is not executed? Okay. So in this one, first exception, then finally block. So if in the catch block I run system.exit 1, this is I hard stopped the JVM. This command system.exit is to hard stop the JVM. Then of course the code will immediately stop, so it won't go to the finally block. That's wrong. See, exception with input 4, and it stopped. So this one, in this case, finally block will not be reached because it stopped in the catch block. Okay. Through this example, I hope you understand what is the finally block. Finally block will always be executed unless there's a system.exit somewhere to stop the JVM. Okay. Now, next topic is try with resource. We will move this topic to the file input output. File input output. So we have class file input output hierarchy. Okay, so we simply go through the top level is input stream. Input stream in Java. Okay. Input and output are two different sides. One is for input, one is for output. In the input, it's a top level. This is an abstract class. And then there's some subclasses like byte array input stream, file input stream, those input stream, object input stream, and so on. Right? Those are concrete class. Okay. This is input stream. Similar for output stream. So input stream is a top level abstract class of a file input output system. This is for the file reading and reading for the binary file. And another is I think is input reader. If I remember, input stream reader. Input stream reader is a bridge from byte stream to character stream. Oh, this is not correct. This is from byte stream to character stream. There's an API for like file reader, I think, like file reader and writer. File reader. Yeah, file reader. File reader extends input stream reader. Okay, so usually we use file reader. You can also use top-level input stream reader, file reader. File reader, then we have a buffered reader. Is reader, and then another one is a file writer to write to a file. Okay, then it extends output stream writer. So file reader and file writer, they are mainly to use to read or write a text file. So we know we have binary file like movie, music, those files, multimedia files, but the text file like our txt file, our Java code, .java or the .json file, or and so on. Okay. So this is API. To do this, if you search online, there are lots of examples to help you of the example code to read and write a file. So here I want to mention about how to read or write a file under the Maven system. Where should we write a file? Okay. Now we try to use the text file. Let me give a new package. Java.io. Let's use IO. So where the file be located? So in the naming convention of the Maven project, we have a source, and so we have a main, and the main we have Java. That's the source, main, Java, right? And the main we can have another name called resources. Create a folder of resources. So usually other resource files, any files, can be put under this resources folder. And there will be another package called called source main resources. You don't have that, so if you if you delete it, don't use this checkbox. If you use this checkbox, the whole project will be deleted from your disk. So you just delete this one, and then you just import it again. This is some basic operations, some tricky operations with this Java. Okay, I'm finished. Okay. Now I need to change it. Compiler. Okay. And close. Okay. Now you can see it's changed to source main resources. So under these resources, you can create folders. You can use source folder, or you can write the file directly. We just write the file directly under this package. This is not package, under this directory. Now let's come back to new class write and read file. Let's do this one. Okay. Wait. So in this class, I only talk about the file reader and file writer, and all of them will be under java.io.star. Okay. Now I provide two methods, like write file with file name. Then I read it back. Okay. Then I provide a static void read file string. Yeah. Yeah. So we can use any file name. So, but this file name will have the source main resources. So I give a name is file full name equals to source slash main slash sources then plus name. As a good convention, we can define this as this root as a constant. private static final string root equals to this one, because we use it for both read and write. Okay, then it's root plus the name. Now with try block, because it will throw IO exception. File writer writer equals to new file writer with this file full name. And after that, you can say writer dot you can say write character array, write string. You can write a string, and you can write a string directly. Let's do this. Write string. Hello world. No, not write string. Okay, is I think is writer dot write. That's right. That's right. But if you want to change a line, you can use the /n to change a line. Then you write another one. Writer write above. Okay, I just write 2 lines, and then I have to close it. Writer dot close. Then I have to catch. The close is very important. Because this is a pointer to the file. To make it safe, usually you need to close the pointer to the file. Then I catch exception. So I print out. An easy way is either print stack trace. That is, you can print all the exceptions starting from another exception and another exception. But if you only want to print this exception, you can just print use error dot print error plus e. Okay, this is write file. Now read file. Again, file full name equals to root plus name. Okay, try file reader. Okay, reader. New file reader file full name. Okay, now reader dot, you can see it's only read int input string reader. So this doesn't look good. So we can have another one is another wrapper. You can see buffered reader. Let's say buffer equal to new buffered reader. This is reader. This is buffer reader. And then you can see buffer dot. We can read. I think it's read line by line. Okay, if we want to read a file, we want to read line by line. But the reader doesn't provide this method. So then I can while string line equals to buffer dot read line. Usually I don't like this style. I just string line equals to buffer dot read line. Then I use while loop. While line not equal to null, because the last line is null. You can read line by line until you go to the last line of the file, it will be null. Then I print out this line, and then line equals to buffer dot read line. Then after that, you have buffer dot close and the reader dot close. Then catch part is the same. Now we do write file, give a name, say sample.txt. Right? Then I read file, sample.txt. Okay. Now let's run it. So you can say reading hello world and hello world. And if you want to make it clear, so you can print out writing file to file class name, right? And also for the reading, you can run reading from file. So we know what happens for the two methods. Okay. Now you can run it. Say writing to file and reading from file. Hello world, hello Bob. And you can see if you refresh the source main, you can use a refresh. And then under that, you can find the sample, right? So since we have buffered reader, we should also have buffered writer to write a line. So we don't have to use /n. So we can use the same way, buffered writer. Buffer equals to new buffered writer. Right. Now here I can write line. Buffer dot write line. Hello world. Do we have buffer? In my memory, there should be something like write line. Looks like it doesn't have, but it has a new line for this one. Not sure about this one. Maybe you need to find some APIs. If you say buffer the write, buffer the new line, and like this, buffer the write, and then buffer dot close. Okay. Yeah, you can do this one. Now let's run it. So we can delete this sample file. And I say hello, Steven. Write a different one and run it. Okay, this is hello Steven. So now this looks good. So we have refresh, we have sample. Okay. Now, next we talk about the try with resource, because we know if we use try and then the two pointer will be close. Otherwise it's not safe. Okay? And the read is the same. And the try with resource has a better solution for that. We can put the two lines in the resource, in the try with resource with this one. Now I don't need this anymore. This is a buffer. So the two lines can be inside. Then I run this one. I don't have to close. With try with resource, the resource will be closed automatically after the try block is finished. And the read is the same. Okay. I run the two lines. And then the two close will be deleted. I just hello Alice. Yeah. So this is try with resource. If you give the code, it's easy to understand. So I put all the resource, like those pointers in the try block. But be careful, this can only be those resources. You cannot use any logic like define x equals to x plus 1. Those things is not allowed in the try with resource block. Yeah. So this is also the new feature in, I think it is in Java 5 or Java 8, maybe Java 8. Let's run it. Yeah. Okay. As a clean code, refresh. I just delete it, and you can check out the code and run by yourself. This is read and write. Now, another important topic is serialization and externalization. Okay, and the serialization and the externalization is if I want to write the whole object at the object level, not a text file, I can use serialization as an object. So let's talk about this. Let's give you an example. So in I/O, I define an object class. Let's say I can use any object, say, let's say person. Maybe I already defined person somewhere else. I don't know. Okay, that's good. I just new class like person. I make a very simple one. ID string name. Okay. Now, next I need to write write person and read object. Write and read object. So here again I import java.io.star public static void main. So person is object. So first I create a person. So I can get ID, say 100, person.set name, say Alice, I give a name. Now I create a method. Again, I need to use this root. I'll copy this root. Now, write person. I write a person here. I give a class name, file name. I use the uniform file name, private. Here, string file name. Okay. So I give a full file name. Full file name. Equal to root plus file name. Now, again, try this time. I use a file input stream. So we know input stream is for the binary file. File input stream, file equals to new file input stream with a file name. Then next, sorry, not the input stream. This is write output stream. This is output stream. Next, the second one is object output stream. Then we say OS equals to new object output stream. Now let's write object person. Okay. Catch exception. Here I print out writing person to file plus file name. Okay. Now I call this method write person. I write this person with file name. Let's say just say persons dot text. Okay. This is a full name. No, let's run it. Reading part, I will do it later. You can see this. You want to write a person as a whole object. It has a not serializable exception. Okay, it's not a serializable exception. It means that if you want to use object output string to write a whole object, your customized object, and you need to implement serializable. Serializable is an interface which help you to do the object writing. So you can implement serializable. It's in IO. In the serializable, there's a serial version UID. You can see there's a warning. So you can click this one. You can add the default serial version UID, or you can use a generated serial version UID. I use the generated serial version UID. Okay. Okay. This is a random long number. Okay. I can remove the. Okay. So this is reading. So if you implement serializable, then you have to guarantee each field is also serializable. We know if you check string API, it also implements serializable. String is an object. String. Okay. If you see the string, so all implemented interface includes serializable here, and there's a comparable. Others we don't care about that, and the comparable, so you can have a compare to method. It's a string. All the primitive are serializable. There's no problem. And what else is serializable for the primitive type or date? Another one is date. Date is also serializable. So you can see serializable. Yeah. But for lots of other objects, they may not be serializable. So if you include those objects in your serializable class, then you have to guarantee that object is also serializable. If one of them are not serializable, then it's not serializable. For example, like object, say top level object Java, object is not serializable. Okay, object there's no not implement serializable interface. So it means what? Let's do it again. I don't need this one. So I just write person. Now I implement serializable, then I can write person to the file. So in the source, you can refresh. You can get this person's text, but actually it's not text. It should be a data file, right? If you open it, it's just a random code, so you cannot see. It's not what you see, because it's binary code, so you can see those special characters. It doesn't matter. I can delete it. Now I change it to DAT file, because DAT file means this is binary file. If you text, it will be confusing. Actually, it's not text file. Okay. So you can run as a DAT file. But why I delete something? Okay. But in the person, it already implements serializable. If I add another private field called object, there's another field. But this object is not serializable. Then if you run this again, it also will create an exception. The reason is still write it. The reason is object is not created and is null. I just new object. I create a default object, and if you do serializable, then there could be an issue, and you can add get and setter. Okay. Now, if I run it, see, not serializable exception. Right? The reason is the person implements serializable. Then you can write person whole person as an object, but inside the person, the field obj is not serializable. So that doesn't work. So this proves that if you want to implement serializable for a class, then each field of the class must also implement serializable. Otherwise, the serialization will be failed. So again, here I talk about what is serialization. So this is a concept. Okay, now let's remove this one. what is serialization and deserialization. Serialization is to convert an object to binary string, and the deserialization is to convert the binary string back to an object. Okay, to an object. Now, okay, so this serialization failed. So let's remove this object and remove the get object and the set object. Oh, and this doesn't this serialization UID I will talk about later. Okay. Now, next let's write another method. Private static void read person string file name. So this is a reverse process, and I just change some API. This is reading person from file. So then file output stream change to input stream. This is input stream, and then object input stream. This is also object input stream. Okay. Now I can get a person. Oh, read person, I don't need to input a person. I just input a file name. That's enough. Person equals to person os dot read object. Okay. Now I can print ID person dot get ID. Name person dot get name. Okay, then I read the person. So I will run it in the way. I won't do the write and person write and read together. So because I need to test something. First I use write person. Okay, now I remove the under resource. Let's say refresh. Okay, let me remove this one. First I write person. So I write person to a file. So then you can see there's a file here, person's DAT. Now after that, I comment this code. I don't have to comment that code. I just comment this code. Then I read person. Person.dat. Persons. Now let's run it. So ID 100. This is Alice here. What if I change the serial version UID? I just remove 6. I use a different serial version UID. Then, if I read it, say invalid class exception. So serial version UID, now you understand what the serial version UID is. Uniquely identify this class. So it means if I write a person using this serial version UID, then I should use the same serial version UID to read the person. Read and write will have the same UID. So I add 6 back, and it will come back to the old one, so I can read it. Okay, it comes back. Now, another thing is the transient keyword. Here I mentioned about transient keyword. Transient keyword means that if a field is transient, then it cannot be serialized. Cannot be serialized. So let's make a test. So in this one, I write person, but I use a transient keyword as the name. Let's say private transient name. Now, first I write person and read. I can run it together. Write person and read person. Okay. Now, see, I can write the person. The person is not written with the name. So after I recover it from the reading, and the ID is recovered, but the name is not. I cannot recover the name. So this is very useful if I have a lot of field in an object, but some field is sensitive. I don't want to expose to the on the other side. Then I will use the transient keyword to do the protection for some field, some sensitive field. So then, based on this example, you understand what is the transient keyword. Now, one question for you is, maybe I have a question here. You can test by yourself. Is static field serializable? This is leave a question for you. You can make a test. You can make a test. So if I have a static field, is it serializable? This is also an interview question. I hope you can answer that question. You can do the test by yourself, and you need to build a good test to prove that. And what is externalizable? Externalizable is another interface, but not like serializable. Serializable, you implement this interface, it's a marker interface, means there's no method to implement it for this interface. But the externalizable is different. You need to have two methods, read external and write external. Okay, we can write another one, a new class, let me write give a record that interface with externalizable. Finish. So we have read external and write external. So for example, if you have a private int ID and a private int record title, like string title. Now you can have get and setters. So in read external and write external is like a transient keyword. You can determine which one you want to read, which one you want to write. For example, I want to write is this is object output. This is we use out, and here I change to in. Right? So I can determine I want to out the write object title. I want to write title. I want to write and write int. ID. I want to write both, and then I can get ID equals to in the read int. Okay. This the title equals to in the read object. Then I do the downcasting to the string. Okay. This is also a different way of serialization, but it has more flexibility to read and write. So you can do the same thing for the record. You can do the same thing as we do here, and I think this is also for you as a homework. You can write and read objects through the externalizable. So then you can see the difference between the serializable and the externalizable is that externalizable has two methods to implement: read external and write external, and then you can customize the serialization. You can in the read external and the write external, you can determine which one you want to read and which one you want to write. But in serializable, you can only use the transient keyword to determine which one you need to read or write. Okay. So transient you only determine you don't want to write something, but when you read it back, all other fields will be read back. But in serializable, even read, you can determine which one you want to read, which one you don't want to read. So this is about those topics. So serializable and externalizable and transient field. And other file input and output, you can go to some website to search it. There are lots of examples to read and write file. But here I give you instruction of how to write file under the source. source main resources. So we will use this folder a lot in our future project. So that's all. There's no assignment for the two topics, but I leave some questions for you, and you can do test by yourself. Thank you very much.